Okay, this is part one of graphing rational functions. When you're graphing these rational functions, there's different parts you need to be worried about, and you honestly want to find these before you even put anything in your calculator to try to graph. This bit right here, we're going to focus mainly on the points of discontinuity. The points of discontinuity are the zeros of your denominator. So this whole section goes back to the fact that your denominator never can be 0 because dividing by 0 is undefined. So what you need to do is when you have a rational function, you're going to need to factor your numerator and your denominator. So on this first one right here, the numerator is as simple as it can be, but your denominator can be further factored into the difference of squares. So that's x plus 4, x minus 4. So when we're looking for our points of discontinuity, those are the values that would make our denominator equal to 0. For every single x you have in your denominator, you're going to have a value there. So since our highest power is 2, we know we're looking for 2 different values. Here, if x were -4, -4 plus 4 would give you 0, so one of them is -4. Here, if x were 4, that would give you 0, so 4 is the other one. And if you didn't know how to get those, just simply set it equal to 0, and there, x is -4. Alright, once you know what your points of discontinuity are, one of two things happens. We have this factored. If it can be reduced, if it can be simplified, if something can cancel out, then the 0 there will be a whole. So see how we have this x minus 4 on top and bottom? Since that can cancel out, what that means is we have a whole at x equals 4. Now our vertical asymptotes are simply whatever don't cancel. So since this one didn't cancel, that means we have a vertical asymptote at x equals -4. And make sure you notice that these two combine to make up these. Points of discontinuity are the zeros of your denominator, but once you've figured out that, those need to be further classified into either a whole or a vertical asymptote. Alright. Number 2 is a little bit trickier. There's a lot more factoring going on. First you got to plot the GCF in both your numerator and your denominator. And denominator and GCF of 3x, and so you're left with x minus 2. I got a room, so come around here. If you do the x box with your numerator, or if you were to factor your numerator, you'd have x minus 3, x plus 2. And in your denominator, you just still have 3x, x minus 2. Okay, so every single 0 of the denominator, so for every x, again we're looking at two different x's here. If this x were 0, the denominator would be 0, so point of discontinuity is when x is 0, and the other one is when x is 2. Our wholes are anything that cancel, and a lot of students think, well, that's a plus 2, that's a minus 2. So that's a tricky almost cancel, but absolutely they're not the same, so you cannot cancel them. But a lot of students do like to overlook this x here and that x there. X can cancel with x, okay? So what that means is that was when x was 0, so that means we have a whole at x equals 0. And that means since the 2 did not cancel, our vertical asymptote is at x equals 2. That is the quick version of points of discontinuity of rational functions. Next, we'll get into horizontal asymptotes.